Hey everyone, I'm Christopher DeBella, a software engineer at Google.
And my name is Cy Brand. I'm Microsoft C++ developer advocate. Today, we're going to be talking to you about documentation in the era of concepts and ranges. So I went looking on Twitter for tweets that I'd sent to motivate this talk, and I came up with this. I like to start off conference talks with a tweet I sent when coming up with the idea, but I don't have a good one, so I'm sending this tweet so I have something to put at the start of my CppCon talk. And now here we are at the CppCon talk. But really, the motivation behind this all was, how do concepts affect our C++ documentation? And we're going to talk about multiple different facets to this. We're going to start off with, what's the state of the art? What are C++ projects doing today in their documentation? Then we're going to move on to what is good documentation? What makes documentation good and fit for purpose? Then how do concepts interact with documentation? By this, we mean C++ 20 concepts. Then we're going to look at ranges in particular, do like a case study on them, C++ 20 ranges, that is. And finally, we'll look at how should we change the way that we document our C++ code moving forward.
So something we should start off with before we move on to the actual content is that everything that we say here are our own opinions and not representative of our employers. We do make some critiques of existing libraries. We think that they are wonderful, but the critiques are made in good spirit. When we talk about this sort of stuff, we're wanting to improve the status quo, not bang on any existing content. So let's start off by talking about what different kinds of documentation there are. We have four main categories of documentation, starting off with design, which details the design of what you have. We have implementation stuff like comments, we have internal APIs and external APIs. And we're really going to be focusing on internal APIs and external APIs in this talk, but a lot of the themes can transcend this and go and be relevant to all four areas of documentation. Then if we burrow down a little bit more, we can see that there are four more kinds of documentation. This is more focusing now on what the user may want. We have learning-oriented tutorials where the user has zero knowledge and we want to get them to a functional state. We have goal-oriented tutorial how-to guides, and those really get people from some sort of place they are now. They already know where they want to be, but they don't know how to get there. Goal-oriented how-to guides will get them from point A to point B. We have understanding-oriented discussions that really give meaning and author rationale behind certain decisions. And then there's information-oriented reference material, which is sort of like the encyclopedia of your API. It covers everything that doesn't really fit into the former three categories. Now, there's a lot of information to understand about this sort of stuff. We're really going to be talking about information-oriented reference material here, but a lot of what we're going to be talking about is also applicable to the other three. Now, if you want to know more about this sort of stuff, you should definitely check out the Write the Docs conference, which covers all of this in far more detail than we could possibly do in an hour.
All right, so let's move on to the state of the art. Where are we today? What are C++ projects right now doing with their documentation? So we're going to look at a few examples, some of which you've probably heard of. One is Abseil from Google, which is a very popular library. This is some documentation from their stir split function for splitting strings. Now, something to notice about this documentation is it's very prose and example driven throughout this whole documentation of this library. It doesn't tend to take the approach of breaking down function signature by signature, looking at what every single argument means and things like that. And it's very much driven by these descriptions in English language and these examples, trying to get the audience to extract from the documentation exactly what they need to get stuff done. So this is generated from a markdown file. It's handwritten documentation. This is not extracted from a header or anything like that. But there is also documentation in the header, which is very similar to the stuff on the web page, but not quite the same. So this is kind of split documentation. You've got stuff in the headers for people like working right on the code there, and then you've also got the documentation for people looking at the web page, and both of these are maintained separately. Another example is FormatLib, which is a type-safe kind of Python style library for string formatting, and which influenced std format, which we got in C++20. And so this takes the approach of, we start off with an overview, why would we need this library? Why should we use it? What are the users saying? And then a quick guide to know, here's how to get started. And then it moves into a little bit more familiar like API documentation. But again, this is taking kind of a prose-driven approach at the top. We've got some examples. It doesn't give a whole lot of like space to each function signature in the style that the Doxygen or something like that does. But I really, really like the style of this documentation. And we're going to look at like why I like it a bit later on. This is generated, actually does use Doxygen, but it uses something else as well. So this RST is restructured text. So this RST is extracted from the header through Doxygen, and then it's imported into what's called Sphinx, which is a tool made by the Python community for documentation. I really, really like Sphinx. It's great. And it looks kind of like this. You've got some restructured text, which is describing the system errors. And then there's some bridge between Sphinx and Doxygen, which allows you to import the extracted documentation from Doxygen and make it into Sphinx documentation. I quite like this style. Then we've got something like LLVM, which is a lot more like the classical Doxygen documentation that you might be used to. I took kind of an unfair example here, but just because we're going to be picking on it a bit later. Some of LLVM's documentation is wonderful. This bit is pretty sparse. Doxygen tends to take the approach of every single function gets its own entry, and these are hyperlinked, and then they're given large blocks where you can check out their parameters and link back to the source, find the references and things like that. There's a lot of space given to each of these, although there's not a whole lot of information here right now.
And then we have libraries like Catch2, which really managed to nail down how the how-to guides that we were talking about earlier. This one here talks about it goes through understanding what's going on with the check and require and how to write a simple test. It does this through Markdown. It's entirely prose written with examples. Again, with Abseil, there's absolutely no there's no focus on the interface any more than just here's what you need in order to get using our API. And they have a great transition document that really tells you how to get from the status quo of Catch2 v2 to Catch2 v3. And it really takes you through all the steps you need to know in order to get from where you are using the version 2 of the library to version 3. Now, this wouldn't be a very good talk titled Documentation in the Era of Concepts and Ranges if we didn't at least talk about a few ranges, libraries, and their documentation as well. So the first one that we'll look at is Boost Range 2.0, which is the precursor to Range v3, which is the precursor to the stuff that we've got in the standard library now. And so Boost Range 2.0 has a great mix of documentation. It gives you usage and gets people to understand what they're walking into, and it mixes that in with understanding the author's motivation about things like why they like the pipe operator. We can also look at Range v3's documentation and see that it starts out really strong and gives a great overview of what ranges are, just like Boost Range 2.0. It then has reference material that's very sparse and doesn't really cover a lot. We'll break this down a little bit more, but this is sort of what the content looks like. And the reason for this is because it's Doxygen driven, just like the LLVM stuff that we were looking at. This is what it looks like. We can see that there's an add to group and a precondition directives for Doxygen. But then Range v3 also has some interesting documentation as well. For example, if you've ever used Range v3 and made a mistake with it, you may be aware that you'll get a lot of template diagnostics from your compiler. If you go and look at the diagnostic that you get back, you'll see that there is occasionally this read this in all caps. And so what the authors have worked out is that they can leverage the way that compilers give their help messages to the public, and because that captures the whole line, including the comment bit of the text, they can say to the user, hey, go and read this thing in the header file. And then you get this nice prose bit of documentation that says, when piping a range adapter, you need to meet the requirements of the viewable range concept. And then it goes on to explain what that means in a much more digestible fashion. Then there's also Range v3 has a great test framework, and that serves as documentation as well. It's probably the best form of documentation in the library, and it's really comprehensive. For example, this chunk view example that I took from the chunk view test is you're able to see pretty quickly, once you know the vocabulary, that this particular range is going to be a random access range that groups the content into chunks of 3 and moves on. Moves on, and then once we don't have a group of 3 elements anymore, it simply gives us whatever's left over. And so this is really what the state of the art looks like. So now what we're going to do is we're going to focus on good documentation. So what's good documentation?
So I looked at a bunch of different sources for this, and these are the main things which I saw time and time again. We're going to break all of these down one by one, but they are fit for context, clear, digestible, complete, accessible, and up to date. So let's walk through all of these so you know what I'm talking about. When we say fit for context, what I really mean there is, if we look back at a few slides ago, we said, what kinds of documentation are there? Design, implementation, how-to guides, reference material. These are all, well, some of them will be for different audiences, right? Like people who are not working on your library likely do not need the implementation documentation, but the people who are likely do. Beginners and experts in your documentation might want different kinds of documentation as well. You need to think about who your audience is. You need to think about who is consuming your documentation and what they need. So this is the first key point that we have in this talk. Know your audience, know who you're writing your documentation for. Think about it explicitly and make a decision who you're writing for and how best to target that audience. We do see the question about CPP references, entries for std ranges, and we are definitely going to be talking about that later. So that is fit for purpose. How about clear, Chris?
So clarity really means how are you communicating your information to users, and can they work out what it is that you're talking about? So let's go back to Catch 2, for example. And Catch 2 has in its very first document that people will go and read, a question. Why do we need yet another C++ test framework? It then goes on to talk about, we have all these other test frameworks. What is Catch 2 bringing to the table, and why should we have a brand new library in an overpopulated sea of test frameworks already? And so it breaks this down by using bullet points and prose, and really drives home what the key features are, as well as what it's tethering together that the other libraries may not be doing. And so when you walk away from this, you will have a clear idea. You'll be able to recall what Catch 2 brings to the table that the other libraries may not be doing. or may not be doing as a collective. So it may be doing as a collective, but not individually. And then we have the how-to tutorial, so the initial tutorial, which is very clear, because what it does is it gets people to do things. It makes it very clear that you need to follow along. It encourages you to be doing what they are doing, and really holds your hand and gets you to a functional state of how to be using this library as your test framework. And then if we go back to the natural expressions page, it only talks about check and require expressions and what these mean and why you would want to use them. So it not only gives you the what, but the why and the how, and it does this somewhat separately for different audiences, which brings us back to the point that Sai was just talking about, which is that you need to know your audience before you can start communicating with them, so that way they understand what it is that you want to be telling them about your library.
So let's talk about digestibility, and we'll pull on some examples that we already looked at. We looked at LLVM. Digestibility here, there's a few facets to this. I think Doxygen here has very clearly delineated all of these different sections, which does help you, skim down the list and work out what you're looking for. It does give a lot of space to these, which might make it less digestible, but they also provide a lot of these hyperlinks to help you jump around and things like that. So thinking about, how is someone supposed to read and comprehend this? Is it just going to be a big wall of text? Is it going to be hyperlinked? Am I giving clearly delineated sections to it? Things like that. Thinking about the layout of your documentation and how to make it more digestible. Again, I think FormatLib does a great job here. These are clearly delineated sections, but it doesn't waste too much space. It's quite easy to scan this, but it's also easy to understand where you are and what you're looking at and what you're looking for. And I do also like that it splits up. It has prose and it has signatures and it has examples. It's very nice. It's very pleasant to read this documentation for me. So these libraries take slightly different approaches, and they might have benefits and cons to each of them. We're not going to tell you what tools to use for your documentation in this talk. I think personally, I really do like Sphinx and handwritten documentation. I think really does help users a lot more than the kind of auto-generated stuff. But what we do want you to do is to consider the tools available to you and use them to maximize your documentation quality. Don't be dogmatic about it. Decide, knowing your audience, what tools are right for you and what you're trying to tell your users, and then use those to maximize your documentation quality. And we're talking about, what makes quality documentation right now as well. So keep that in mind going forward. There's also the matter of completeness, and not to rag on this LLVM stuff, but this is not complete. There's a lot of information missing here. If I want to call this LLVM get bitcode module 2, there's a lot of information I'm missing. Maybe I know this because I already know the rest of LLVM, and I know that, it's probably requiring the memory buffer to be set up like this, and this module ref is supposed to come from this other place, but this is requiring a lot of the user. There's a lot of information which is potentially missing here.
And then once you've got complete documentation, you really do need to think about accessibility. Accessibility comes on two different axes, so we're gonna consider them in turn. So let's take an example of splitting a string in C++, because we've talked about how Absal has a string split, and now there are other ways. There are many other ways that are popular in C++ to split a string. So let's go onto the web and search for how to split a string in C++. And this is the first page of a web search, and nothing that is popular comes to mind. There's nothing about standard splitting. There's nothing about Absal split or Boost split or any of the other really popular libraries on this matter. It's a lot of questions about how to split a string, but not necessarily what conventional ways there are. Now, fortunately, C++20 introduced a way to do this. So we're going to just teleport to CPP reference and take a look at the split view that C++20 gives us. And so let's say that we don't know how to use the library just yet. So we're met with an interface and that's not particularly descriptive and a lot of text. So let's scroll down. And we want to scroll down a bit more. And we want to scroll down just now to, okay, so we had to do a bit of scrolling. I think there was 4 times we had to do scrolling to get to the example that shows us what it is that we need to be doing in order to split a string. And so the idea of accessibility here is that something needs to be easy to find and easy for your audience to comprehend what's going on. CPP reference has a very broad audience. It caters not only to beginners, but also to experts who just need to look up a handful of things and move on. But the information, it may not be organized in a way that's accessible to everyone. It focuses on the interface first, and which makes it easy for people who already know what they're looking for to get started, and puts the beginners toward the end because they need to scroll down toward the end. So that's the first axis of accessibility, making sure that your audience can access the information that definitely is appropriate for them. The second axis is accessibility for people. Now, not everyone is going to be like us, so we need to make sure that we are writing our documentations that way we cater to the broadest audience possible. And that means that we need to consider things like having text, so that way screen readers can pick up things instead of having images. And that means not only just screen readers, but we can increase the font size without destroying resolution. And if images are absolutely necessary, then we should be thinking about having alt text, so that way screen readers can pick up what the image is supposed to be showing. Now, we are not going to go into much of this because it's a very complex topic, and it's not, we don't have the bandwidth in this talk to actually spend time talking about it. It could take up its own talk itself. So we are going to defer accessibility guidelines to the Write the Docs conference, where you can learn a lot more, and they give the appropriate time for this particular axis of accessibility. And then finally, we have documentation that good documentation should be up to date. Now, if we go back to the Abseil example, you'll recall that Sai was talking about Abseil having a prose-based documentation that you can find on the web. And then there's also the comment-based documentation that you can find in the header of the str split, where str split lives. This is something that we both really like, and we'll get into why that is in a few moments. But it does require a fair amount of vigilance, because you may have someone who decides to contribute to Abseil, and they could go and update the interface in some way, and then they see that the documentation is in the header, and the header gets updated, but they're not aware that the web page documentation isn't auto-generated from the header documentation, like it would be with format lib. These are two separate things that need to be maintained. And so then the burden gets placed on the maintainers, and if the maintainer isn't paying attention, they approve it and it gets merged into main, then the documentation is now out of sync, because the code-based documentation is correct and the web-based documentation has suddenly become stale. And stale documentation is worse than useless, because it gives people the wrong idea about the interface. So even though we are fans of having this multimodal documentation, you need to ensure that all your documentation is up to date in order for it to be considered good documentation. Now, the reason that we both the reason we like having this multimodal documentation is because it caters to different audiences. We took a survey a few weeks ago about what users like to see. And we can see that the vast majority of people want to have external documentation. A small majority of that vast majority also want to have internal documentation. Now, we define external documentation as stuff that you can find on the web that's easy to look up. And then in the internal docs refers to the comment-based stuff in the headers. So different audiences want different things, but almost everyone wants to have the external stuff available. And so what we're really trying to say here is that you should be measuring your documentation on several axes. That means that you are ensuring that your documentation is going to be accessible to the broadest possible audience, and it never goes stale. You ensure that it is catering to as many people as possible, and it's always up to date.
So that's good documentation. Thinking about measuring your documentation quality on several axes, all the axes we just talked about. And now we'll move on to how do concepts interact with documentation. So, Chris, what is a concept?
So a concept expresses the requirements for some sort of algorithm, and their concepts are broken down into three different kinds of requirements. We have syntax requirements, semantic requirements, and complexity requirements. And we say that a type model is a concept if it meets all of the requirements that we've just talked about. Let's take the size range concept, for example. We have some type R and an object of that type. The size range concept on R, we say that documents that R is a range. That means that we can call ranges begin on R and ranges end on R. And then we also need to be able to call ranges size on R. And when we call ranges size on R, it will return the number of elements that R has in amortized constant time, and that ranges size doesn't modify R. And then furthermore, if R models the forward range concept, then ranges size is always going to be available.
So let's look at an example of how concepts interact with documentation. Let's consider this function here, register callback. So this is a function which takes some type, an object of some type f. What do we know about this type f? Well, maybe we can intuit that since this is called register callback and the type is called f, then it's some kind of function, which is probably a fair guess, but we don't know a whole lot about the function. If we wanted to tell the user about this, then we could provide them some documentation, say like, you have to pass a callback which takes a void star. Say we're using this to pass on things to a C API or something like that. But right now we don't have that. We just have register callback some function. So say we pass a closure which takes an int instead of a void star. What happens now? Well, our compiler shouts at us, right? We get a compiler error, and we need to do a little bit of sleuthing to work out what this means. You can kind of work out at the bottom, this is saying cannot convert void star to int for first argument. So you kind of work out that we pass something which expects an int, whereas it was wanting something which takes a void star. We think about it a bit. What if we decorate register callback with a concept? Now, this std invocable says that f is some type whose instances can be called on an instance of void star. So it could be a function pointer, it could be a closure, it could be a function object, it could be anything which you can call the void star or invoke with a void star. This is both documentation to the user and to the compiler. Right? If we look at this and we know what std invocable means, then this becomes shared vocabulary between me and the implementer of this library, between other users and the compiler, shared vocabulary between everyone. And this is kind of reflected in the compiler error. This is from Clang. Clang says that if we do the same kind of thing, we pass something which takes an int instead of a void star, then it says candidate template ignored, constraints not satisfied because std invocable of our lambda and void star evaluated to false. Just pretty clear compiler error, I think. So we're starting to think about this as concepts both communicating to the user and communicating to the compiler. Let's look at a slightly more complex example. Let's say we have a function called Cartesian product, which takes a bunch of ranges and returns something representing their Cartesian product. This has some more complex constraints on it. All of our V's have to be viewable ranges. So this is something we need to understand in order for it to become this shared vocabulary between us and the users and the compiler. But once we understand that a viewable range is something which is either not owning its elements, like it's a range view adapter, or it might be an L value, so it's not going to own some memory which is going to go out of scope at some point, then it will be a viewable range. Once we understand this, we know what we're asking for. It also requires that all V's be forward ranges, and also that we pass at least one range. So once we've comprehended this, we as users understand what we're talking about. The compiler also understands. If we do something like pass an R value vector to this Cartesian product, an R value vector is not a viewable range. It's going to go out of scope. So we get compiler error. It says constraints not satisfied because std vector int does not satisfy viewable range. So what we're really trying to say here is concepts are a tool which you can use to express constraints to the user and to the compiler at the same time. So when we say that we want you to use the available tools to maximize documentation quality, when we talked about like Doxygen and Sphinx and stuff earlier on, concepts can be used as a documentation tool. This is another of our key points for this talk. Concepts can be used as a documentation tool. We will be expanding on this very shortly when we move from talking about how concepts interact with documentation to our case study, which is C++20 ranges. So Chris, what is a range?
A range is essentially a type that, or a pair of types that allows us to iterate over some data structure's elements. The range is denoted by an iterator, which points to the very first element in what we call the range, and then a sentinel, which describes the rule for finishing the range. And so the way in which we describe a range type in C++ is that we can call ranges begin on the range, and that will give us back the iterator. And then we can call ranges end on that object, and it will give us back the sentinel that denotes the rule for finishing. We have different kinds of ranges, and those different kinds of ranges provide different functionality. We've already seen how a sized range is a range that also allows us to call ranges size on our range object. But we also have things like random access range, which are required to have a random access iterator as the iterator to the first element, because that means that we can do some fancy things like being able to arbitrarily step over some number of elements instead of having to sequence our way through them one by one. This means that we can hop from point A to point B in constant time. And once we know this sort of stuff, we can think about how we should be documenting ranges. Now, a bit of a backstory here. Last year, I was asked to be a volunteer lecturer during COVID for a university, and that was on a C++ 101 course where students had already had 2 years of prior programming experience. I wanted to teach ranges in that course and realized that CPP reference didn't have much in the way of documentation for ranges. So what I ended up doing was I went and looked at how the algorithms for the C++ 1798 algorithms were documented, and used that as my basis for the range-based algorithms. And this is what I ended up with. So I showed this to a friend last night, and they said that they'd never seen so many colons in their life. So I am a bit concerned that this documentation that I happened to start off last year is not meeting our guidelines. What do you think about it?
Well, I mean, technically, we did say that concepts are a tool for documentation. So, I mean, I guess it's fine.
Yeah. Okay. So what, if I could paraphrase you here, what you're saying is that concepts can be used as a documentation tool, but the documentation tools, like anything else, can be misused, and that means that concepts can also be misused. So that basically means that just because we are saying that concepts can be a documentation tool, that doesn't mean that you should start going and throwing concepts on everything to document stuff, because that does end up conflating the documentation and making it very intimidating to read. Does that answer the question from earlier?
I think we will now answer the question from earlier. How should this look? So let's think about how this should look.
Right.
Chris, do you have any suggestions?
Yeah. So after a bit of thought, came up with this idea of putting the example that's at the very bottom of transform up to the very top. We talked about accessibility earlier and how beginners have to scroll through a lot of stuff. Scrolling through that split view is nowhere near as difficult as this transform example. So what we've done here is we've transposed the example to the very top and put the API into a section underneath and explicitly denoted that it's the API. So what do you think of this over the previous one?
I think this is definitely an improvement. I think what we're missing for absolute clarity and making sure it's fit for purpose is a description of what this actually is. You know, we're kind of assuming that someone's coming to this knowing what they're trying to do. We don't have any high-level explanation of what stood ranges transform actually does.
Right. So how about we take what you said, apply it to CPP reference. We'll put the description at the top that explains what ranges transform is supposed to be doing and what a user can expect from it. And something that I realized when I was editing is that something that I particularly like to do is not remember which headers things belong to. I really rely on CPP reference for finding out which headers things go to. And because it's such small text and is not in any way impeding anything else, I had this idea of putting the header that this stuff is defined in back at the very top, then the description, which is in much larger text, so it gets people's attention. But the people who want to be frequently not remembering things and just using this as convenience can still interact with stuff. So I think this takes the best of both worlds and caters to two audiences at the same time. So what do you think about that, Sai?
I do think that this is a huge improvement, even without really changing the content of the page. Just thinking about our audience again, thinking about what people are going to come to this page looking for. This is a huge improvement. You know, we've thought about our sections, we've organized our information, thinking about our audience, thinking about making it digestible, clear, understandable. We've known our audience, right? We've been thinking about the audience all the way through this. So I think this goes some way to answering that question from the start. I think that even just restructuring that information could make a huge difference. But then we're also going to think about how we could use concepts in slightly different ways to document in a bit. So one question is, can my range be const? So we've got, like Chris said, we've got lots of different kinds of ranges we can have. If I have a range, can I const qualify it and then iterate over my members? This is available in some ranges and other ranges do not support it. So how do we know? Well, we want to check the documentation to see if this is supported, right? So let's say we go to CPP reference and we want to know if our join view can be const iterable. Okay, so the first thing we need to know is that we need to check the begin and end member functions for join view. So let's scroll down and then open up the sub pages for begin and end, and then look at those signatures. Then we need to know that we need to check the const qualified versions of begin and end. And knowing that, we can work out that our join view is const iterable as long as our our const version of our underlying range is an input range, and its reference type is a true reference, i.e. not a proxy. So we kind of got there. It required me to have a bunch of domain knowledge already existing. It required a bit of sleuthing. Maybe there are different ways to deal with this. And maybe there are other questions similar to this that we might want to ask. Can you think of any, Chris?
Sorry, can you please repeat that, sir?
Yeah, what are another question we might ask?
Oh, right. So what one thing that comes to mind is, can we pass our range.begin and our range.end to a classical algorithm? So we talked about earlier that that a range is something that has an iterator and a sentinel that denotes the end. But in C++98, we had ranges that had an iterator to denote the beginning, and then a second iterator, which was one past the last element that denoted the end of the range. And that's what we call a common range. So it's a special class of range. And so things like vector, that's a common range because it has a pair of iterators, not an iterator and a distinct sentinel type. And so you may be thinking, well, if we're using ranges, why are we using the C++98 algorithms? Maybe someone's written a library that's in the C++98 era and all the way up to 17, and they haven't gotten around to a sentinel-based algorithm yet. So this is the sort of stuff that we're thinking about here. And so we need to have a common range in order to use this style of algorithm. So let's take a look at lazy split view and see if this is a common range. So it turns out that if we have an end where the range is both a forward range and a common range, then we have a common range on our lazy split view. But while this is kind of implied by the first overload, we do need to take a look at the prose documentation. That's not so bad, but the second overload is really where we want to be focusing on, because it's got absolutely zero context from its interface. And then we need to go and take a look at the prose, and we see that it returns an outer iterator or a default sentinel, depending on some of the requirements. Then we have to go and take a look at this logic to find out, what the actual content we're getting back is going to be returned. So we take a look at the logic, and we see that we've got to have a forward range, and then the range when it's const qualified also needs to be a forward range, and then again when it's const qualified, it also needs to be a common range. And only then can we get back a common range. Otherwise, we have a non-common range. And this is pretty wordy, pretty difficult for someone to get through. It took me a few reads myself in order to understand what this was saying. So I think it doesn't really communicate stuff clearly and get people to understand what's going on here. I had to go through quite a fair bit to get here. So now we should be thinking about, well, what does the user of a range actually need to know? The stuff they should know are things like type requirements. This comes in the form of concepts with all three kinds of requirements. We have pre and post conditions. We want to know how we can construct the range, what happens when we dereference the iterator. Is it going to be a reference type, or is it going to be some sort of object that we're getting back? What is the range's category? Is it going to be an input range? Is it going to be a random access range? Will the range be sized? Do we actually get back a common range? Will we be able to const qualify it and iterate over it? And finally, is the range what's called a borrowable range, which is something that was only introduced late in the C++20 design cycle. So let's take a look at how other libraries present this. We'll start out with Range v3's stride view. This stride view is a way of skipping elements in some constant number of elements. And so if we take a look at this particular bit of documentation, we can see that it's very sparse and there's not particularly much going on here. So it's not really addressing the needs of the user, which is telling people how to use it or even what it represents. So it's not really fit for context. It doesn't clearly state what or how to use it. So it does unfortunately lack clarity. And it's not particularly digestible because there's not really anything to digest. And that then kind of follows on to it being incomplete. It did take me a while to find this particular thing as well, so it's not particularly accessible, but it is up to date, and that's mainly a consequence of its the documentation being so sparse. So this is an analysis of the high-level sort of stuff that we want for good documentation. What about for what the user needs to know? Well, it does have some of the type requirements. It says down the bottom that we need to have this integer-like thing on our difference type, but it doesn't tell us anything about the range. It also doesn't tell us the precondition on stride, which we'll get to in a little bit. There's no information on how to construct or use this. We don't know what we're going to get back when we do reference it. The iterator, we don't know if it's going to be an input range or if it's going to be a sized random access range. We don't know if it's going to end up being a common range or if we can iterate over a const version of this. And we don't know if it's going to be borrowable either. So this is a look at range v3's documentation. Then we have boost range 2.0 strided, and we'll take a look at how that's contrasted against range v3. So immediately there is a lot of documentation, and it talks all about strided and not only how to use it, but things that it gives you an example. So it's fit for context. It's very clear what's going on. It lays out everything in bullet point formats and gives you an example down the bottom. It is digestible because it's broken up into sections and has tables and bullet points. It isn't complete, unfortunately. It does cover things like the precondition being that you have to have a non-negative integer, but it doesn't tell us what kind of ranges we're allowed to pass in. It's accessible partially because it's 100% text, which means a screen reader or going up to 200 or 300% in your web browser is going to be very easy to do. Unfortunately, even though this particular Boost library has a great table of contents, it unfortunately still took me quite a few clicks to get to the strided documentation. So I'm only going to give it partial credit here, but it does seem to be up to date, which is great. Then let's take a look at what the user needs to know. We've already covered that the type requirements aren't present, and this was one of the things I said wasn't because it was which ruled out it being complete. It does cover the preconditions, which is great. It shows us how to construct, not only using the constructor, but how to use the pipe syntax, and tells us about that. And unfortunately, it doesn't tell us about the reference type, but it does mention that the range category is a single pass range, which is essentially another way of wording that it is an input range. It doesn't mention that whether or not it's sized, unfortunately. And then the last three things about being common, considerable, and borrowable, I'm going to give it a bit of a pass on because Boost Range 2.0, I think, came from the 2010 era, and these last three things came from at least the 2014 to present era. But that doesn't mean that I'm going to give it. I'm not going to bring these sorts of things up. This could go a long way to completing the documentation by saying, hey, we're now in 2021. Perhaps we should at least address that even though the library doesn't cover this sort of stuff, we are still documenting that these kinds of features are not present in this particular library. So, how should this information actually be presented, in our opinion?
Yeah, so I spent a lot of time thinking about how should we actually be documenting these things. And one of our key points earlier was concepts can be used as a documentation tool. So let's think about how we can apply concepts and all of those axes we've been talking about in order to improve this documentation. So we're going to do cycle view. This is range v3's just for comparison. So what we're going to start with is a high-level description. We're going to say cycle view turns a view into an infinitely cycling one. And then we're going to have an example. I think this is a great way to have clarity, to be fit for purpose, to make it digestible. Mostly users like examples, right? We want to get going and get something up and running. For something like view cycle, this is perfect. So we start off with a high level description and an example. Then we start to break out our concepts. So we have our type requirements. We require that V is a forward range and a view. Our reference type is the same as V. Our category is a little bit more complicated, so we break it down into bullet points. It's random access if V is random access and size, and a few other details. And then at the end, we have it's never sized or common or borrowed, but it is considerable if V is considerable. These are all things that we could work out by looking at the signatures, but this just lays it all out for us using that shared vocabulary of concepts. If we understand what forward range is, we understand this documentation, and so does the compiler. And then we tell you how to construct it. We say that you can pipe it without any arguments. We give you an example, and we show how to construct it with the function call syntax. So we said to measure your documentation quality on several axes. So let's think about this. Fit for context, I think we've thought about our audience, what the audience needs. I think it's clear and digestible. We've laid out clear sections. We've used headers. We've used bullet points. We've thought about how to lay out this information. You would think about how to lay it out on a web page, which might be slightly different, but just for slides, you can kind of imagine how this would transfer. Complete, again, this is we're thinking about what a user needs to actually use this library. So I think it's complete in as far as that criteria goes. Accessibility, again, this would kind of depend on how you actually translated this to a web page. Up to date, so this is handwritten and hand maintained. And if you change something in the signature of one of your types, then you might affect these things in a non-obvious way. So you would need to be careful there. Let's look at a slightly more complex example. Let's say chunk by key view. So this is one which is maybe not quite so obvious, like cycles, but chunk by key is a view which chunks a range into subranges, where the consecutive elements share the same key given by a projection function. So this is kind of a mouthful. We need to know what a projection function is, things like that. But so we have an example. So we have cats, like Marshmallow here. You can say hi. This is Marshmallow. He's very soft, very sleepy. So we have cats, and our cats have names and ages. And then we show how to chunk these cats by age. So our first group has those first two, which are 12. And then we have another cat who's 9, and then 2 more cats who are 12. And you see these are split into 3 groups, consecutive elements with the same key given by a projection function. Then we break out our concepts. So we say that requires forward range, requires view, and then we have this slightly more complex one, indirect unary predicate. So again, this is something you would have to know, or it's something we would decide to instead or additionally describe in prose. Then we have our reference type. Our reference type is starting to get a little bit complicated as well. We've got a stood pair of an indirect result of calling this function and a subrange of our iterator. So maybe we think this is starting to get complicated, so we give an example. We say if v is vector of int and f is a function from int to bool, then you get a pair of bool and a subrange of vector iterators. And you see that this is kind of on the line of where we would consider documenting purely with concepts or switching to something else. Like Leslie had a question. Some documentations hide spine stuff in the signature and use plain text to describe the requirements. So maybe we could do something like that here, or we could factor some of this out into a detail concept or something like that. There's a lot of things we can do as long as we're thinking about our audience and all of those qualities of documentation. And then we go on to the other concepts, which are a bit easier to handle. Category is always forward, never sized, common, considerable, borrowed. We show you how to construct it, and then we show you how to use the piping syntax. And I think this is all the information that we need. So Again, I think what's good documentation, this kind of is very similar to the other one, fit for context. We've thought a lot about our audience. We're trying to think if this gets any more complicated, we might want to display things in a slightly different way or factor things out. Again, it's going to be hand maintained, so we need to consider that. But I think that this is a good way of documenting these kinds of range adapters by taking that shared vocabulary of concepts, using it for the users and the compiler, but always thinking about the user, always thinking about our audience, always considering these axes of documentation. So now that we've kind of looked at ranges a little bit, let's think, how should we change how we document C++ code? What do you think, Chris?
So as users, what should we be asking of our implementers? Well, what we should be asking is for our documentation to be fit for context. We should be asking that it be clear and digestible. It needs to be complete, accessible, and up to date. This is really all the stuff that we've been talking about throughout the entire session. One of the questions that was asked was, how can we get sites like CPP reference to change the documentation style? Well, there are a couple of ways that we could do that. It definitely comes down to getting them to do it and asking them to do it. There are discussion pages on things like CPP reference that you can weigh in on and say, hey, I'd like it to be changed. You could go to the hashing Discord channel and CPP reference and talk over there. There's multiple ways to do it. It is a wiki, so you can make the changes yourself if you feel strongly enough about it. But the discussion section is a good way of getting this, getting support for this sort of stuff. But something that we really do want to drive home is that if you don't ask for this sort of stuff, it won't get better. A compiler dev at a CPP, at a standard C++ meeting a few years ago said that the only reason we don't make compiler error messages better is because users don't complain about them. That's pretty harrowing. Compiler error messages are something that really should be good and helpful. And so you need to start asking for things to be better so that way the world can improve. Take, for example, Range v3's header-based thing where we talked about how you need to notice this read this bit and then know that means please go to this header, and then you get the pros documentation, which is fantastic. What if instead of that, the compiler had a way for the library dev to actually put this message into the diagnostic that you got back, so that way the user could see what it is that's going wrong in prose. Now, once you've finished convincing a compiler engineer to implement this and getting it implemented into your compiler, you then need to go back to your library devs and say, hey, the compiler uses this, please start using it so that way we can actually get better documentation and better diagnostics for the library that you're maintaining. Something we're really driving home here is that if you're not asking to change, it's not going to get any better.
So let's also think about, as implementers, how do we help our users? And I think this just comes back to all of the key points we've made throughout this talk. Those are, know your audience, think about who you're writing your documentation for and cater it towards those people. Measure your documentation quality on several axes. We gave you a bunch of axes you could consider. Maybe you have your own axes. Maybe there are things that we don't know about your audience that you do, and you can then use those as criteria for guiding your documentation quality. Use the available tools to maximize your documentation quality. We're not going to tell you what tools to use. We don't want you to be dogmatic about it. We want you to consider what's available to you. Concepts can be used as a documentation tool, and I think we've shown you good ways that you could do this, but they can also be misused. Don't just use concepts as like a bludgeon because the compiler understands them as well. Think about your audience. And I think if you follow all of these key points, then your documentation will be much better. Thank you very much. Okay, we've got about 1 minute for questions. I think you kind of answered the one about CPP reference, Chris. How do you strike a balance of properly documenting an API without over-documenting? This is a very good question. I think that a lot of this comes down to thinking about your audience. Of course, for something like C++, a lot of the time your audience will be a dual audience of maybe people who are new to your library and people who are advanced. So thinking about how you can present this information in a way which is useful to both of those people, like putting those examples at the top, or potentially hiding advanced information behind like a check button or something like that. Just thinking about your audience and thinking about what they need and what different cohorts of your audience will need. Do you have any thoughts on that, Chris?
Basically, what you just said, I think sums up everything that I was thinking as well.
Cool. Maybe we got we're almost at time. If anyone has a last question, can maybe ask. Marshmallow is currently trying to burrow his way out of my room, which is kind of impressive. But we will be kicking around the Gather Town space if you have any further questions, or you can reach us both at Twitter. I'm at Tartan Llama. Chris is at CJDB_NS. Marshmallow is on Twitter a lot as well, or you can reach us on Discord. But thank you very much for joining, and we hope that you enjoy the rest of the conference. See you.
Thank you.